All right, I have 11:15. We are going to get started. Please pull up your Tinkercad circuit from last time. I am also going to activate a poll. Just asking how confused you are about what we did Monday, because I realized that went pretty fast. So I'm going to start today's lecture by recapping what we did on Monday, not repeating the entire lecture, but kind of an overview of the code we wound up with by the end of lecture. And then we are going to learn about something new called interrupts today. But I'm going to leave this open because I know people usually kind of tend to trickle in for a couple minutes. But I want to be able to just glance at the responses and see how confused everybody is so I can kind of calibrate going over this. But remember, our goal here was just really simple. We wanted to link an input to an output. Okay, I run this program, or start the simulation in Tinkercad. When I hold the button down, the LED turns on. Great. When I release the button, the LED turns off. We are doing this with buttons and LEDs because the hardware is very simple, but you are going to have a robot that is reacting to sensors, right? So your inputs are going to be different sensors on the robot that we haven't learned about yet. Your outputs are going to be controlling your H-bridges, which are controlling your motors. You can also add LEDs to your robot for decoration if you want to, but that's not going to be the main point of it. Okay? In our program, we have this pop-up to go away. And if you're just joining us, there is a poll everywhere open. I'm going to leave that open as people come in. I'm going to look at the responses so far. Okay, and it looks like we have kind of a decent spread between super confused, kind of confused, in the middle, and I think I get it. Okay, kind of a normal distribution around the middle. I'm going to leave that open. And if you're just coming in, there's a poll everywhere open. So, recap of what's going on here. Okay, we have a main function. We have some code that only runs once, and then we have a while one loop with code that just runs forever, okay? Because this is a microcontroller, there is no operating system, there is no other program running on it. We don't really ever want to exit this program. This is it, okay? Our only job in the world is to respond to this button press, okay? In the main function, remember, we are not using the Arduino language. If you're familiar with Arduino, you might remember the pin mode command that sets a pin as an input or output. You're not allowed to use that in this class. We are using the data direction register, so DDR-D or DDR-B, depending on which port you're on, which you look up in, if I can find my mouse, the Arduino Uno pinout diagram. Okay, so if you zoom in on this diagram, it'll tell you which port and which bit in each port corresponds to which pin. Okay, if you set the corresponding bit in that register as a 1, that sets that pin as an output. Okay, it acts like a voltage source that we can control or turn on and off. These registers, all the pins default to inputs, so they default to all zeros. So technically, I don't really need to write out DDR-B equals a bunch of zeros to set this button as an input, because it defaulted to an input. But if I want to do that to remind myself, hey, I set this pin as an input, I can do that. Okay? We initialize serial communication, because that is useful for printing out messages for debugging. As your code gets more and more complex, that is going to become more important. That's all we do in the main function, okay? Just 3 lines of code. In our while loop, we are then going to do something, I forgot to actually use this word last time, something called polling. So we are just continually looping and checking this input. I'm just going through this loop, and at the beginning of this loop, each time I have an if statement that checks if this button is pressed. So this is the part I'm not going to pull up the separate slides and go over it again, but last time we looked at bitwise logical operators and masking. So how do I check if just this pin is high? And remember, we talked about how your first instinct there might be to use a double equal sign. No, it won't let me edit one run in the simulation. Okay, say, hey, I want to know my button is on bit 0 of port B here, so I want to know if pin B, which is the register that, so I got a question about this before class, what's the difference between pin and port? Pin B reads the values of the pins, okay? It monitors whether each pin is high or low. Port register is what you use to set the outputs, so turn something on or off, okay? So you might want to say, okay, if pin B equals that, then I know my button's pushed. That works in this program because this button is the only thing on port B. But imagine I had 4 other buttons or something. So I'm adding multiple buttons and multiple LEDs. This would only be true if that button is pushed and none of the other ones are pushed, right? If I push the other buttons, or if I have some LEDs on port B and those LEDs are on, then this would not be true, right? So if I just want to respond to that button press, then I need the bitwise AND operator. Again, I'm not going to go over how masking works again today. That's in last time's lecture notes, and there's a video about it on Canvas if you're confused about the bitwise masking stuff, okay? So you can think of this, again, if you're familiar with Arduino, using a digital read command, which will tell you if a pin is high or low. So you can say if digital read, whatever the pin number is, equals true, then that is just checking that one pin. Here with the register, we need to do the bitwise operator. Okay, so think of this like saying if the button is pressed. Okay, your if-else statement then works exactly like it does in MATLAB or Python, right? Except here we have to have the curly brackets around the actions, which I don't think you need in either of those languages, right? So we say, if the button is pushed, we're going to do some stuff, else the button is not pushed, we're going to do some other stuff, okay? In this case, if the button is pushed, I just want to turn the LED on. I do that with a bitwise OR operation, so that's the little vertical bar there. This line of code only turns that pin, pin 7, on. Again, it doesn't really matter in this program because that's my only LED. But if I had a bunch of other LEDs and I only want this button to control that one, then I need to use masking so I don't affect the other pins, okay? Else, same thing. I only want to turn pin 7 off. I use masking with the bitwise AND operator again to only turn pin 7 off, okay? So, again, simple program with just one LED and one button, but your robot's going to have multiple sensors and multiple 4 signals going to the H-bridges, right? So you don't want to accidentally set everything low when you only wanted to change one pin. That's what the masking is for, okay? Again, I didn't pull up and go over the bitwise stuff from last time again, but do you have conceptual questions about what this code is doing or how it's doing it? Okay, push the button, LED on, release the button, LED off. Okay, I realize we went through that super fast on Monday, so I kind of want to make sure we're on the same page before we keep going today. Everyone believes me? Okay. So, now as I mentioned, this is called polling. We are just looping through and continuously checking this input, which can work fine in this simple situation with one button and one LED. What if I had 10 buttons? Okay, what if I had to loop through and check each one at a time? Or what if I just had some really, really long program doing a bunch of complex calculations or something that took a non-negligible amount of time to run? Okay, I am not, rather than writing a really long program or actually adding 10 buttons, I'm just going to simulate that with a delay. So last time, I forgot to mention this, we had this short delay, just 10 milliseconds at the bottom here. And I forgot to talk about debouncing really briefly. A button is a mechanical thing, right? Or a switch, you push it and there might actually be some springiness or oscillation in the electrical contacts. So it might actually go, you only push the button once, but the internal electrical contacts can vibrate a bit and it might kind of oscillate high or low really quick. So sometimes after pushing a button, you might add a really short delay to just tell the code, hey, wait a second to make sure the button is stabilized before we do anything else. Okay, but what if I make that delay a lot longer? If I make that, say, 5,000, so there's a 5-second delay, which in computing time is forever, but I want to demonstrate this, I want it to work on a human time scale that we can see, right? Now, if I run this program, I have a problem. The LED doesn't necessarily light up when I hit the button, right? I can sit here and hold it down for, let's see, there we go. I held it down for long enough, now the LED is on. Okay, that's happening because now rather than just looping through this really, really, really fast, I'm getting stuck in this delay for 5 seconds. Okay, so if I push the button and I'm only 1 second into this delay, I have to hold the button down for another 4 seconds before the code gets back up here and checks the button again. Okay, and again, you can imagine if I had 10 buttons, so I had 10 of these if statements back to back, or I was just doing a whole bunch of math or something that takes a non-negligible amount of time, it's probably not going to take 5 seconds, but for things that need to react really quickly, right, seconds and fractions of a second matter. Okay, so not ideal, right? Just think about your robot. Your robot is going to have sensors detecting the line on the edge of the arena. you don't have a whole second to wait to detect the edge, right? If you're driving forward full speed, you're off the board at that point. Okay, you need to detect that and react to it instantly. So to do that, we are going to learn about something called interrupts that, as the name implies, can literally interrupt the code when a condition is triggered. Regardless of where you are in this while loop, it's going to jump out to a separate function. So we're going to switch over. Actually, before we do that, if you came in late, there is a poll everywhere open just to gauge how confused you are about last time. Please go ahead and respond to that so I can close it. I'll give it like 15 seconds. Or if you're having poll everywhere trouble, okay. Everyone good on poll everywhere? Still having login issues? No. All right. If you can't log in, come see me after class, and I'll jot your name and that ID down because I'm going to close this. 5, 4, 3, 2, 1. Deactivate. Looking at the complete responses. Okay. Again, we're kind of a normal distribution around in the middle and get ever confused. Next one. This is another poll everywhere sting operation. Do not answer it if you are in this room. Hopefully word has gotten out that people should not be replying from home by now. We're at 0. Maybe people finally get the message. Okay? I'm going to leave this open for another 15 seconds just in case. Again, if you were here or if you just got here, do not reply to this one. Okay. 5, 4, 3, 2, 1. Yay, 0 replies. This is the first time we have ever successfully done that. Okay. All right, we are going to switch over to PowerPoint for a second to talk about interrupts, and then we are going to jump back to Tinkercad for the rest of the class. Okay. All right. The problem with polling, this is a link to a demonstration of what I just showed you, right? If you have a long delay in your code or your code's taking a long time, then you're not going to respond to the button press right away. Okay? We're going to address that with something called an interrupt service routine. So we already saw we have our main function, we have our code that loops forever. The interrupt service routine is a separate function that can interrupt this code. Okay, so there's going to be there are multiple different kinds of interrupts that we will be learning about over the next couple of weeks. But the code kind of automatically in the background will monitor for the condition for that interrupt to fire, jump up to that function, and then go back to wherever it was in the main function when that happens. Okay, and you see there's a argument for the ISR, short for interrupt service routine vector. What that vector is going to depend on the type of interrupt. So again, we're going to learn about more of those as we go on. And then we're going to see this little command, SEI. This enables interrupts. So we're going to see there are both registers we have to deal with, and this kind of global command to enable interrupts, to turn interrupts on, otherwise they won't work. Okay? Specifically, we are going to be looking at digital pin interrupts. So how do I detect either a rising or falling edge on a pin? Remember, these are digital pins. They only read either 0 volts or 5 volts. So if you hook up an oscilloscope to one of those pins and push a button, right, you're going to see the voltage go from 0 up to 5. And if you sit there and keep pushing the button, it's kind of going to look like a square wave. Right, so if we look at the Arduino pinout diagram, again, there's an overwhelming amount of acronyms right here. Do not worry about all of them yet. Today, we're actually just going to look at one type, but there are 2 types. So today, we're just going to be looking at these 2. Ignore all of the other information on the screen right now. Just look at this red box. int0 and int1. Okay, connected to Arduino pins 2 and 3. Okay, there's also a bunch more of these PC int labels that work on every pin. We're not worried about those yet today. We're just doing int0 and int1 on pins 2 and 3. Okay. What's the difference? And again, I'm going to post these slides. I'm not going to stand here and read all of this to you. Again, if you imagine looking at the voltage on a pin where you're pushing a button on an oscilloscope, you have low voltage, rising edge, high voltage, falling edge. The external interrupts on pins 2 and 3 there can fire on either a rising edge or a falling edge or both. You can choose for the interrupt which one of these edges you want to detect. The pin change interrupts always trigger on both rising and falling. You can't pick. So we'll talk more about the differences of those, between those on Friday, and you'll see that in both the homework and lab 4, which you haven't really gotten to yet. Okay, I'm not going to read through these slides. These are going to be posted if you need to then go look it up to remember how to do it for the homework. We're kind of going to switch back to Tinkercad to do a live demo here. So again, this will all be posted on Canvas. If you don't remember the process, there's a slide that tells you the steps. Okay, how do I set up one of these interrupts? We're going to go through a live demo doing it in Tinkercad though. Okay, so I'm going to exit out of there. I want you to make so remember, as you're doing this, don't just keep overwriting the same Tinkercad circuit all the time. You want to make copies of these and give them names kind of corresponding to each function. So you want to call this one something like polling, or polling with a button, whatever makes sense to you. Make a copy of this one. Okay, so go back to your main Tinkercad page, click the little gear icon, click duplicate, make a copy and call it external interrupts, or something similar, okay? So same hardware, we're not going to change, well actually we are going to need to change what the button is connected to, but we're going to change the code, okay? So I want you to, again, copy the circuit, but delete the code that's in your main function, and delete everything in your while loop. You can keep the serial begin because we're still going to use that. So we're just back down to this. Okay? Give everybody a minute to get the copying and code deleted done. Okay? All right, first thing we're going to do, in the last demo, I had my button connected to pin 8. External interrupts are only available on Arduino pins 2 and 3. Okay, so I'm going to take the jumper wire from my button, and this time, rather than choosing a different pin, I want you to follow what I'm doing, use the same pin, and then you will set it up an additional, depending on how much time we have left today, you will set it up with an additional button for the other pin. Okay? So I'm going to move that down to pin 2. Okay, remember, keep your wires neat. Okay, we have an external interrupt available on pin 2. Now, to enable that interrupt, we're going to need to do some stuff with registers, and we're going to need to write our interrupt service routine. So that goes up above your main function, ISR, parentheses, we didn't fill in the vector yet, open curly brackets, close curly brackets. So this is going to be code, caps, code that runs when interrupt triggers. Okay? We need to fill in the vector or the argument for this interrupt service routine that corresponds to the one we picked. Okay? That information is in something called the interrupt vector table on Canvas. Okay, so down in the Arduino section, same section as the pinout diagram and all that stuff, there is a table that gives you the vector name, zoom in here, corresponding to the interrupt you're using. Okay, so we are using external interrupt request 0. If we look at the Arduino Uno pinout diagram, we'll zoom in here. See, we're connected to pin 2, which is int 0 here. That is external interrupt 0. Okay, and the vector name for that is int0_vect. So in my code, I'm going to write int0_vect. Okay, that tells me this ISR is linked to that interrupt. Again, you could have multiple interrupts, and they can do different things. So you have to have the correct vector there for the one you're using. Okay, and again, the process for doing this and reference to the documents and everything is going to be in the slides that I'll upload if you don't remember how to do it from now. Okay, everybody with me so far? All right, now to enable this interrupt, we need to set a couple register values in our main function. Okay, so we're going to go to the data sheet Again, this is this 400-page document. Go to page 80, not 189. And again, if you, come on. Let me delete the 1. I don't know. 9? Not 891. There we go. You should have this open in another browser tab in Canvas. Seriously? Okay. Oh, there we go. It's lagging. No. Okay, screw it. We're just going to scroll. Dear God. 17. We're still scrolling. I'm going to zoom in while we're at it because it's kind of small. You guys might be able to get there faster than me. Jump ahead to page 89 in the data sheet. $79, getting there. 90, okay, went too far. All right, this is the section of the data sheet for external interrupts 0 and 1, okay? Then we have 2 registers here. The EICRA register, external interrupt control register A, and the external interrupt mask register, EIMSK. Think of these like the controls that turn the interrupt on. So just because I created that interrupt service routine doesn't mean the interrupt is on yet. I need to set the corresponding bits in these registers both to turn the interrupt on, and remember how I said for this interrupt you can choose rising or falling edge or both. I need to tell it which one of those I want to detect. Okay? So first one I'm going to do here, EIMSK, the external interrupt mask register. So you see this has this kind of bar labeling different bits in the register. If they're just grayed out, that means you just leave them as 0, they don't do anything. Okay. If they have a name, so we have int1 and int0 here, you have to read the description to see what that bit does and figure out what you want to turn on. So for here we have int1 and int0, and I'm not going to stand here and read this whole paragraph to you, but bit 0, it's called int0 here, is the external interrupt request 0 enable. So when that bit is 0, the interrupt isn't even enabled. Okay? If I want to enable the interrupt, I need to set that bit to 1. Okay? Think of this like the control to turn the interrupt on. Okay? So to do that, and I don't care about these other bits, these are all just 0, and I don't care about int1 because I'm not using int1 right now. Remember, int1 is the one that's connected to pin 3. I don't have a button connected to pin 3 yet. I don't care. I just leave that one as 0. It's off. Okay, so in my code, in my main function, I'm going to type, look at, right piece of paper, capital EIMSK equals 0B, 7 zeros, 1, 2, 3, 4, 5, 6, 7. 1, semicolon. Okay, that is taking this register, setting all of these values to 0 except for that one. I'm setting this bit to 1 because I want to enable external interrupt 0. Okay, so write yourself a comment, something like enable int 0, datasheet page, I think that was page 90. So you can find that again. Okay, yep, datasheet page 90. Okay? So I've enabled the interrupt, but I haven't selected rising or falling edge yet. Okay, to do that, I'm going to go back to the datasheet, scroll up to the EICRA register, which is a little more complicated, right? Okay, now I've got 4 bits that are just grayed out. I don't care about them. But I've got 4 different bits here, and they are kind of labeled below in these different values in tables. Okay, so see, this table is about int1. I don't care about int1, I'm using int0. This table, int0, gives me 4 different options. So any logical change on int0 generates an interrupt request. The falling edge of int0 generates an interrupt request. The rising edge of int0 generates an interrupt request. And there's also one just for low levels. So if the voltage is held low, it'll just keep triggering the interrupt, okay? So setting these bits 1 to 0, for ISC0N, where N equals 1 or 0, so that's ISC01 and ISC00 here, I need to choose from this table which function I want. Do I want rising edge, falling edge, or both? We're not really going to worry about the low level part. I'm going to want any logical change. Okay, so we're going to detect both rising and falling edge. We'll explain why in a minute. Which means I need to set those two bits to 0, 1. Okay, again, I am plugging this value from the table, 0, 1, in for these two bits. Okay, I'm ignoring these two because those are for external interrupt 1, which I'm not using right now. Okay, you're going to come back and do that at the end of the lecture with a second button, but for now we're just doing this one. Okay, so again, I'm going to go over to my code. I'm going to type EI to CRA. That's the name of that other register. And this one is also going to be 0B, 7 zeros, 1, 2, 3, 4, 5, 6, 7, oops, 1. Okay, again, that is setting these two bits to 0 and 1, leaving the other ones all 0. Okay, again, add yourself comments. Something like select rising and both rising and falling edge for int 0. Data sheets, I think that one was page 89. Data sheet page 89, second table or something like that, so we know where we got that information, second table. Okay? So, I've set up my interrupt service routine to be triggered when I detect either a rising or falling edge, so when I push the button or when I release the button. Okay? This register enables the interrupt. This register selects whether it's rising or falling edge or both. I need to add one more line of code. I still, oh, whoops, broke up my comment there. I need that SEI, open close parentheses, semicolon, for just enabling interrupts globally. Okay, you see, even if you do the individual registers, if you don't have this SEI line, interrupts aren't turned on to the microcontroller, so it still won't work. Okay? And now, I'm not going to do anything with the LED yet. I'm just going to put in here something like serial println interrupt triggered. Now, if I run this and didn't screw this up, oh, what the hell? Void vector. Error expected, oh, I forgot, a semicolon at the end of, so if you ever see this expected semicolon before token error, that means you forgot a semicolon at the end of a line somewhere. Again, if you're coming from MATLAB or C, you're probably not used to needing that. Okay, start simulation, open serial monitor. So if I click the button once, okay, that was my rising edge, that triggered the interrupt. I release the button, I get a falling edge, and it triggered the interrupt again. Okay, so I can sit here and keep happily clicking the button, and I should keep triggering the interrupt. Notice how there is no code in my while loop. Okay, the program is just buzzing along in this loop until it detects an edge, and then it jumps to the interrupt, and then it comes back down to the while loop after the interrupt is over. Okay, so general rule of thumb for interrupts is you should keep them short and not do anything too crazy in them. Crazy being kind of a nebulous term because it may do weird things to the rest of your program. So doing something like toggling an LED is fine, then you go back to your main function. Okay, everybody have at least just the print statement working. Okay, questions? Yes?
I connected the LED the same way as you did. It always displays the explosion mark for the Arduino.
Connecting the LED displays the explosion mark for the Arduino?
Yeah.
Okay. Then you probably have your button wired wrong. It's not the LED. So if you have your button pin set, did you delete your DDR registers? It will show the Arduino as exploding if you short an output pin that is set high or low to the opposite voltage, either 5 volts or ground. So I don't want to pause to look at it right now, but you probably have something wrong wired with your button. So double check that. As long as you don't have any, you have no DDR or port registers in your code at all. Okay. So again, the LED should not cause things to blow up, but the button can cause things to blow up. Okay. Was there another hand in the back somewhere? Yeah, way in the back.
So just to clarify, it is supposed to be interrupted when you're pushing the button and releasing.
Correct. And that is because of the EICRA register here. We selected the values from this table where it says any logical change, so that means rising edge or falling edge. If we selected different values here, then it would only trigger when you push or only trigger when you release, depending on which one you select.
So which register, which value would you pick if you only wanted to interrupt when you push the button?
That would be depending, the way we have, so the question was, which value would you pick if you only want to interrupt when you push the button? With the way we have the button wired, you would select rising edge. Because we have the button wired with a pull down resistor, so it is low by default and it goes high when you push it. You could wire it the other way with a pull up resistor, so it is high by default and goes low when you push it, and then you would select falling edge. So it depends on how you have the button wired. Okay? All right. So we have set this up. Okay? Just to print interrupt triggered when we push or release the button. We're not doing anything with the LED yet. Okay? I want you to add code to turn the LED on when the button is pressed and leave the LED off when the button is not pressed. Okay? Add code to control the LED. Okay? And you may want to look back at the masking stuff from last time. Okay, so as a hint, to get you started, we have our register setup code here. You still need your data direction register here. Okay, so we still want to set your LED pin as an output with a data direction register. But then you now can control your LED. Instead of doing something in the while loop, you can do it in the interrupt service routine. But you're going to have to be careful with masking because we now have our button and our LED on the same port. Did you get yours figured out?
So it's all going
Make that a lower, I believe it's case sensitive, so make that a lowercase vect. So you need 0 vect in the ISR argument. Yeah, sub-simulation. I'm glad this came up. I am 99.9% sure all of this is case sensitive, so make sure that that is a capital int 0 underscore lowercase vect. Okay. You did not move the wire for your button. Your button is still wired to 8. You need to move the wire to 2. Okay. Remember to move the wire for your button to pin 2. Okay. External interrupt 0 is only available on pin 2. It will not work if you left the wire on pin 8 or another button. Yes.
The second G and G. That's below the 5.
So are you gonna get your tire on place?
Yeah. They have warranties here. Well, so I got my it's a lot,
Is there a line on this? Is that what I'm doing wrong?
Everybody have the LED working? Raise your hand if you have the LED working. Okay, not a lot of hands up. So, hint. You don't need an if statement at all to do this. How many of you were trying to do it with an if statement? Okay. So, my LED is going to default to off. Okay, so I'm going to set it as an output with my DDR register. That's 0B, 1, oops, capital B, 1, 1, 2, 3, 4, 5, 6, 7. And again, remember, if you hate writing in all the zeros, you could also do that with bit shifting. So DDRD equals 1 left shift 7. Same thing. Okay, so I've set my LED pin as an output. I'm not doing anything to control it yet. Remember, I want it to turn on when I press the button, so when I have a rising edge, right? And then I want it to turn off again when I release the button. Now I could, since this interrupt is going to trigger on both rising and falling edges, I could write an if statement in here to read the pin register, just like I did with polling, to detect if the pin is high or if the pin is low, and then set the port register accordingly, right? But I don't need to do that. I can do this with one line of code. Port D, XOR equals the bitwise XOR operator. Does anybody remember what that does? What does XORing something with 1 do from last time? Toggle. Okay, 1, 2, 3, 4, 5, 6, 7. That is going to toggle the bit each time this interrupt fires. Okay, so I start, button is not pushed, LED is off. I press the button once, I get a rising edge, bit is toggled, LED is on. I release the button, the interrupt fires again, so bit is toggled again and LED turns off. Okay, so I don't even need an if statement. Okay, on, off, with no code in the while loop and just one, not counting the serial prints, just one line of code in the ISR. Okay, don't have to do it like that. Again, I could do it with an if statement, checking the value of the pin D register to see if the button is high or low, but way cleaner like that. Okay, so give everybody a minute. I mean, we had one weird Tinkercad issue where it looked like everything was wired right, but the interrupt was not firing for some reason. But I'll give it a minute or two and see if everybody can get to that point. Again, it's just fine. You don't have to use different pins. You can just copy my setup for now. Yes?
So, that most recent line that you added, what was that to again? Port D?
So, port D, that little up caret thingy, is the bitwise XOR operator.
Okay.
So, remember from masking last time, there's three different masking operators, OR, AND, and XOR, right? ORing something, and they each do different things depending on whether you XOR it with 1 or 0. Okay, they can either change a bit or leave the bit unchanged. This line of code toggles bit 7 without changing any of the other bits. So if you XOR something with 1, and this is in a table from last time's lecture notes that I don't have pulled up right now, but if the bit was originally 0 and you XOR it with 1, then the output of the resulting bit will be 1, right? If the bit was originally 1 and you XOR it with 0, then the output or the new bit will be 0. So it toggles the bit. It always flips the state of the bit. If it was 1, it becomes 0. If it was 0, it becomes 1.
And every new iteration and swap.
And it'll just keep. So every time this interrupt fires, which is on both rising and falling edge, it'll just keep flopping the bit on and off, or turning the LED on and off. Okay? Yes?
Okay, so since the button's plugged into pin 2, why would you toggle the port T to pin?
Because the LED is on pin 7. I'm toggling the LED on and off. That interrupt triggers when the button is pushed or released, and then I am toggling the pin that is controlling the LED on and off. Okay, remember the LED is an output, right? I want to control the value that is turning the LED on and off. So that is why I'm using the port D register to change this pin high or low.
So then, does the EI MSK and EI CRA, do these kind of detect the buttons list?
Yeah, so the question was, is the EIM, so these registers are setting up how this interrupt is triggered. Okay, so remember, if we go back to the pinout diagram, okay, so that trigger is this interrupt is only available on pin 2. Okay, these registers are selecting which change we want to detect. I'm actually going to go back to the PowerPoint for a second. If I were to hook up an oscilloscope, there we go, to the pin that the button is connected to, there we go, and look at the voltage, right? I would get this. Push the button, voltage goes up. Release the button, voltage goes low. Okay? Those registers are selecting which of these events will trigger that interrupt service routine. I can select just one of them, just rising edge, just falling edge, or I can select both. I have selected both. So what I have done is then using that toggle in the ISR, I say my LED is initially off, interrupt is triggered, I toggle the LED so the LED is now on, I release the button, interrupt is triggered, I toggle the LED again so the LED is now off, and that just keeps repeating as I push the button. Okay? Let me go back to Tinkercad. All right. Does everybody have this working? Again, you should be able to just copy exactly what I have, which is basically a free homework problem. I forget which one, but getting you to do this behavior with an interrupt instead of polling is like problem 3C on this week's homework or something. Okay? With the remaining time, I want you to add a second button and a second LED using the other external interrupt. Okay? It's okay if you don't finish that, but I want you to get started. So you will start by looking at the data sheet. Okay, so the other external interrupt is on pin 3. So you will need to connect a button to pin 3. You will then need to add another interrupt service routine to your code. Okay, so I'm going to write this down. Oh, the simulation's running. And actually, before you do that, maybe make a copy of this circuit. So you have one working version with a single external interrupt, and then make a copy for 2 external interrupts, okay? Connect. Button to pin 3. Pick another pin for another LED. Okay, write ISR for int 1. Look up vector interrupt table. Okay, so you'll need another ISR, and if I look at this table, that one is going to be int 1 vect instead of int 0 vect. Okay, and then you're also going to need to make changes to the EIMSK and EICRA registers to enable external interrupt 1. Okay, so there are your instructions for how you would do that. And again, these instructions are also, if you don't have a chance to copy those comments down, these instructions are also in the slides you can upload after lecture today. Okay, so you're duplicating what we just did here, but that will give you 2 separate and independent inputs and outputs. Okay, so each one will be controlled by an interrupt. So even if there was a bunch of stuff going on in the while loop, which there isn't, right? In this program, the while loop is just blank, but if you were doing a bunch of calculations or some other stuff inside the while loop, each one of these outputs would fire instantly on the button press. So we interrupt the code, jump up to the ISR, and then go back to the while loop, okay? We got 3 minutes left. Again, I realize you're probably not going to finish that, but I want you to at least get started on it so you have it going forward, either for the homework or for your robot. If you get stuck or have questions in the remaining time, raise your hand and I will run around. Yes?
Oh, it sucks one.
Hmm?
So it does the same thing as last time where, like, if I click, as long as I push the button, it turns on and then it turns off.
Rashida, do you have it?
Yeah.
No, you don't.
Oh, it's grayed out. Is that what you're saying? Because my simulation is running. Oh, wait.
Oh, there is something like that is weird.
Oh, it's like this.
Oh, this is from
If I do that, right? If
The good news is that the homework asks you to do this with your real hardware and not the Tinkercad, so if you can do it before in Tinkercad, it should work with physical right
see how it's going?
now. One thing you can do for debugging, just like you would with the physical kit, actually,
Well, you can click and drag to like select.
so if this comes up either in Tinkercad or with your physical homework, don't forget that your multimeter exists. Okay, both your multimeter and your oscilloscope. This is a good debugging tool where, again, if it's not working, okay, you're pushing the button and the interrupt is not firing, you have a couple debugging tools at your disposal, okay? One is the serial print inside the interrupt, so you don't know if the interrupt is firing in software. Forget the LED, you can put a print statement there just to see if the interrupt is triggering. The other thing is maybe you're not 100% sure your button is wired correctly. You can hook up a multimeter or an oscilloscope and make sure the voltage on this pin is changing. Okay? If you hook up a multimeter to measure the voltage in this row of the breadboard, it should change between 0 and 5 volts when you push the button, either with Tinkercad or with your physical Arduino at home. If you do that and the voltage never changes, then your button is not wired correctly. Okay? We are out of time. If you have questions, as usual, I will stick around and we will talk about pin change interrupts on Friday. Thank you.